Today we're going to talk about design patterns for enterprise applications. You already know a little bit about design patterns because of the work you've done in previous modules. So this will be a very quick overview in terms of the general idea of design patterns. We know that design patterns describe general problems and their general solutions. Design patterns apply to problems that can appear in many different contexts. These general solutions will not be absolutely just what you want for your specific problem. And it is fairly well accepted that what you would need to do is to take the general solution and customize it to your specific application. Design patterns are tried and tested solutions to problems. They have been used in industry for many years, sometimes decades. And because they're tried and tested by industry experts, they work and they are reliable. Very often these patterns will also give guidance on alternative solutions to the same problem. We would need to spend time thinking about those alternatives and considering which one might be best for our specific problem. Design patterns also provide a vocabulary that will help communication between developers and designers. It will also improve documentation and maintenance. For example, if we talk about the facade, then I don't have to give you any more information than that because you already understand what a facade is. And that's how design patterns can be used in communication between members of a team. We might very well say, oh, we're going to use a table data gateway for this. And if you're familiar with that particular pattern, you know immediately what is expected. As a very quick recap, these are the various tiers of a Java Enterprise Edition application. And the design patterns that we can use will apply to one part or another of that application. In this lecture, we're going to focus a little bit upon the tier that we're going to be calling the domain layer, which really sits in the business tier. That's where the application logic or the business logic sits, and where we have to interact with data sources. So we'll talk a bit about that kind of design pattern. There are also other design patterns that can be used to facilitate interaction between clients and the JavaEE application. And we'll talk a bit about those as well. If you want a lot more information, then you need to get a good book or some reliable, credible website that you can go to. One of the best books I've found for enterprise applications is this one by Martin Fowler. He presents 51 different patterns that are grouped in the various layers of an enterprise application. Two of the patterns that he talks about are the remote facade and the data transfer object. We've mentioned both of these during the course of this module. Remote facade we're using when we want clients that are outside of our Java virtual machine. We want to enable them to interact with our application. And so we'll provide a remote facade for the session beans. What it means is that the clients then will have access to the business layer through the session beans, and they won't have direct access to the entity classes. And that's really quite important in my view, because the entity classes have got a direct connection to the database. And I don't think it's a very good idea for clients and other parts of the application to have access to the database. Data transfer objects are used to move data between the web tier and the client tier, and also between other tiers within the application. Let's think a little bit more about the remote facade for now. You can see from the diagram on the left that without a facade, each of the various clients will have to access the server-side components via the network, and those clients will need to have a fairly detailed knowledge of the various components within the application. They'll need to know not only what the components are, but which should be accessed first and which next. And that means that we're going to build into the client quite a lot of detailed knowledge about the structure of the application. The problem with that is if the structure of the various components changes, then we've got to change the clients as well. Also, the clients are going to have to send quite a few calls across the network to access the various clients. And calls across the network are many magnitudes slower than calls within the same virtual machine. And so that kind of an approach is not really ideal. A much better approach would be to provide a facade. From the diagram on the right, you can see the impact of using a facade. The client no longer needs to know anything about the application server architecture. It just needs to access the facade. And all the detailed knowledge about the components and the order of access and so on, that's all built into the facade. The client just calls a method in the facade and the facade does all the hard work and returns to the client the result of that hard work. If we make the facade coarse-grained, it means that one call will return as much information as possible. Whereas if it's fine-grained, such as on the left in those diagrams, the client will make a call and get a little bit of data back, make another call to another component and get some more data, and so on. Fine-grained interaction means that there will be many calls, and that means, if we're using the network, quite a lot of waiting around for the various responses. And so one way of improving the effectiveness and the efficiency of the communication between client and server is to reduce the number of calls across the network. Making them coarse-grained will achieve that, because one call to a facade method will achieve a lot of work in the server side, but it's the facade that's directing that work, and so those are local calls and will happen much more quickly than the network calls. A data transfer object can also help to reduce the amount of communication across the network. Here we've got an example of some very fine-grained calls going through the network. The client is calling the EJB using a remote facade, but calling for little bits of data at a time. Give me the first name, give me the last name, give me the address, now the phone number. And all of those calls are going to take a lot of time. Much better if we could encapsulate all that information in one object. The client makes one call asking for all that information and it comes back as one object. And that's the purpose of the data transfer object. It will encapsulate all this data. It will remove the need for fine-grained network calls. The EJB, receiving the message, get me the customer information, will consult with entity classes and so on to get the data, bundle it into an object, and then send that object back across the network to the client. A data transfer object, because it needs to move across the network, will need to be serializable. And because it's serializable, it can then automatically be sent across various data streams, written to file, written to memory, and sent across the network. DTOs are very often used with a remote facade for the reasons we've discussed in terms of efficiency and so on. We can use DTOs as parameters and/or as return types. The idea about a DTO is that we package as much data as possible into one object. As far as possible, DTO attributes should be primitive types or references to simple objects. Don't make them references to other more complex objects such as other entity classes, because that will increase the amount of serialization that has to be done. So much better to get all the information that's needed in a DTO. I'll show you an example in a moment. Now, DTOs exist only to transfer data. Therefore, there should only be the access methods, the sets and the gets. There should not be any business logic. There should not be any persistence logic. It's just a box into which we drop data and then send the box across the network. And it might well be that we want to make these immutable objects. Immutable objects are those where we use the constructor method to set the initial values for the attributes and then only provide get methods. So the values that are set in the constructor will never change for that object. A DTO might actually contain data from one or more domain objects. For example, if we've got a customer entity class, we might very well have a customer details DTO. On the other hand, let's look at this diagram, a sequence diagram. we can see that there's a servlet that wants to get car and manufacturer information. Now, car information will come from a car entity object. Manufacturer will come from another entity object that, because of the persistence API, will have automatically been set up with data from the database, and the relationship between them will have been managed in collections and object references. But we don't want to send the car entity object and the manufacturer entity object across the network, so we'll put those into a DTO. One approach would be to say, okay, let's have a car DTO and a manufacturer DTO, and have the car DTO reference the manufacturer DTO. That wouldn't be wrong, but it means you've now got two objects and you're sending information with two objects. Another approach would be to do as shown here on the sequence diagram, which is to have this car DTO factory, which is a factory method. That's another design pattern. And the factory method in here is going to find the car information using the persistence API, which will get the car entity object and the manufacturer entity object, and then call the various get methods to obtain the data and put that data into the car and manufacturer DTO as one object, and then send that one object across the network. So there are various ways of doing this, and there might be pros and cons for each, but don't go away with the idea that you have to preserve the domain object relationships in data transfer objects. Factories and builders are different things. They're both creational patterns. From the point of view of the client, there's very little difference between them, other than the client will say, I want this, that, and the other, now build it for me. Whereas with a factory, you'll probably just send a code, and the factory will know from that code exactly what to do. And that's really what's happening here. We're sending the car primary key to the factory, and that's enough information for the factory then to go off and get the various objects that are all related to that, build it all in one go and send it. Now, sometimes we might have to wait a while because it could take some time to get some information gathered together. If a client makes a request, it might then have to block, and we'll sit there and wait until the response comes back from the Façade. And that might not always be desirable. One way that we could deal with that problem is to use message-driven beans as the Façade. The client will send a message to the message-driven bean, and because it's asynchronous, we'll carry on processing, and eventually we'll get some kind of notification to say that it has a response ready for processing. So we don't have to go with synchronous calls. We could make them asynchronous. And here we've got an example of somewhere in the application layer, a JMS message being sent to the services layer, which is a message-driven bean. The onMessage method will do all the business logic and eventually will make some kind of response if a response is needed. In this example, a response isn't necessarily needed. On the other hand, if a response is needed and it's asynchronous, well, we could have the client sitting listening to a queue. And so the message-driven bean might then put a message into a queue that goes back to the client. So we could have asynchronous messages going in both directions. And here's a sequence diagram for that kind of a scenario where the message is sent to the message-driven bean. It then does all its bits and pieces with the various components within the application. Let's change our focus now to the domain layer. There are three patterns that we're going to look at: transaction script, domain model, and service layer. Transaction script is actually quite intuitive. It's the kind of thing that we might do if we've got a very small application and we've got some use cases. And what we would do is to organize the domain logic into sets of methods, procedures. Each one is essentially a script for one transaction, in other words, one use case. When the request comes in for that use case, there will be a set of activities that have to be performed. When we're using the USDP, those activities are described in the activity diagram for that use case. And so we could write a procedure that will implement that use case's activities. Each procedure will very likely interact directly with the database rather than making use of entity classes. There are three examples here on screen: browse hotel availability, or book hotel room, So all the data will come in on that request, and then that one method will deal with all the checking and the booking and the returning of relevant information. The advantages of a transaction script are really straightforward. It's quite intuitive, as I say, and there will be little overhead in performance because there's not a huge amount of communication going on. And it is really useful for small and simple applications. The disadvantages are to be found when the system gets bigger. As the system gets larger and larger, we'll probably find there's a lot more code duplication going on between the scripts. For example, database access. They'll all want to access the database, they might all want to check availability of rooms, and we'll be duplicating that code within those scripts. Now we can mitigate against that to some extent by factoring out common code into methods that can then be called from each of those transaction scripts. But still, there's some extra complexity that gets built in as the system gets bigger. It becomes less scalable with a transaction script as your application gets bigger and bigger. A different pattern that could be used then is the domain model. Now, this is quite different from a transaction script. This is very much an object-oriented approach where we will model the domain entities in an object-oriented way with object-oriented relationships. Each of those objects will represent some meaningful thing in the domain. It might not actually be in the database like that, and if that's the case, as we shall see in a moment, we'll need some kind of mechanism for facilitating the interaction between a relational database and an object-oriented model. Both business logic and behavior is defined in methods, and we might find that there are all kinds of design patterns being used within a domain model, depending on how rich the model is. If it's not terribly rich, it may very well be very similar to the database structure. And if that were the case, you might decide to have one class per database table. In other words, this is a table data gateway pattern. Or you might have each object represent a row in the table, which is the row data gateway pattern. Or you might decide to have an active record, where you have some business logic in with the persistence logic that sits within the object. On the other hand, you could come away from the database structure entirely and have a very rich OO model for your domain. And as I mentioned a few moments ago, that will mean that you'll need some kind of mechanism for mapping, and data mapper is one of the patterns that Fowler talks about in his book. You'll need some kind of mechanism that will map and compensate for the difference between a relational database and a rich object-oriented model, because they won't be the same. One of the ways that you can do that is using a data mapper, and the Java Persistence API is an example of a data mapper. And it sits between the domain model and the relational database and takes care of keeping the two synchronized so that there is no incompatibility between the data in one and the data in the other. One of the great advantages of using a domain model when it's properly designed and structured means that it will reduce or even eliminate code duplication. The whole idea about object-oriented classes is that they should each have just one responsibility, one reason to change. And so they will have very focused responsibilities within each of the classes. And that means that we'll reduce or eliminate the duplication. It also allows us to use OO features, and it can handle complicated and changeable business logic, and can do so in very adaptable, scalable, extensible ways. But one of the disadvantages is it can be difficult to map to a relational database. The third pattern that can relate to the domain layer is service layer. And what it will do is to put essentially a facade between the rest of the business logic and the domain layer that models the business domain and access to the database. And there are two kinds of service layer. One is a domain facade. This is a thin class, so it will simply delegate responsibilities to the appropriate domain components. You can visualize this, I think, in a similar way to what we saw earlier when we were talking about a remote facade for clients interacting with the presentation layer. Well, here this is for not clients as in remote clients, but clients that are within the presentation layer maybe, that are then interacting with the application layer. And so this service layer will act as a facade to make the dependency between presentation layer and application layer much smaller. Or it might be an operations script, which is a thick class. In other words, it's very much like a transaction script for the domain layer. What it does, especially if we implement these service layers using stateless session beans, it means that we can take full advantage of the container managed transaction. It separates domain logic from application logic. That's a good thing. It defines a common set of operations that are available to different types of client. That's also a good thing. If you've got different types of clients, such as a web browser or a mobile device, you might have common functionality that you want to use once you get past the interaction between client and server. And once the client has submitted the request in its own way, then all the rest of the processing behind that is common. And that's what we've seen with the enterprise application architecture, that once you get to the session beans, thereafter it should be common architecture and common components between them. Putting a service layer in front of that will indeed facilitate that, and as we mentioned a few moments ago, stateless session beans are a great way to implement a service layer. A disadvantage is that it's not always easy to identify service layers. One of the ways in which you could do that is to partition your application into major themes. For example, student services or contract services or product services. Then have essentially a facade for each of those partitions, and those facades are the service layers. A couple of thoughts about distribution or clustering. With distribution, what we're doing is we're taking the components of the application and, I was going to say scattering, but it's a little more engineered than that. But we're scattering those components across different machines so that there isn't any one machine that has to do a lot of work. And that will help in terms of responsiveness. Although we're spreading the workload across different machines, it does have a bit of a downside because that we then have to have remote communication between components within the application. And as we discussed a little bit earlier, the more remote communication you have, the slower the response time. Now, clustering compensates for that because with clustering, you take the entire application and put it on a machine and then put another entire copy of the application onto a different server and so on. So you can have multiple servers, all of them with the complete application running. Now that means that the communication between components on the same computer will be local, not remote, and therefore that communication will be very efficient. What it will need then is a workload manager, so that when a client sends in a request, the workload manager will have to determine which of the several servers running the application is going to be best placed to process that request. In other words, who's got some spare capacity at the moment to handle this request. Now, if we distribute, that's going to increase use of remote interfaces, reduce application performance, and require coarse-grained interfaces. You don't want to have fine-grained interfaces when you're using remote interfaces. On the other hand, if we're clustering, it's going to keep remote interfaces to a minimum, which will improve application performance and will allow fine-grained interfaces. And according to Fowler, this will yield better maintainability with a simpler programming model. We don't have to worry too much with clustering about how do I get this component to talk to that component on a different computer. It's all within the same virtual machine. That's as much as we're going to say about design patterns. I've only scratched the surface of that today. You will probably benefit greatly from getting hold of a good book on these patterns and taking some time to delve into those patterns a bit more, and then try to apply some of those to your assignment.